used to, or get used to, multiplying by 1/7. That's going to make your life easier long term. I'm going to pause for a second so you can write down any notes you want.
Mr. Ken, I got a question. So you said it's 10 right there. Why it ain't 20? Because you do 4 times 5 then 4 times 2.
Mm-mm. Remember, what is that 4 understood to be divided by?
1.
Right? So that's 20 divided by 2.
Oh, okay.
Good question. Does that make sense?
Yeah.
Okay.
Alright. I learn something every day in class.
That's what I like to hear. Okay? Alright. So, the whole point, right? 7 divided by 7 is
1.
1, right? Remember, what is that 1 called? The 1. Multiplicative identity, right? Because what's 1 times x? 1x, so x is equal to 42?
Mm-hmm.
Okay. We good on that? What?
You lost zero.
Y'all, I need y'all to look back at your work.
I got a question.
You need to question things that I do sometimes. Yes, Sharnavia. Huh? How did you word it?
Yeah. I thought that was right. But
Wait, say that again, Savannah? I thought it was 6 too. Oh, wait.
Yeah, you just
Yeah,
was 6.
Bruh, come on.
So we got it wrong.
Look at you.
Is it 6 or is it 42?
It's 6.
How do you know?
Because
You do it. You work it out.
Because you plug in.
By 42 divided by 7. 6.
Okay, so I'm gonna get to that in a second, but I want you to remember, what is a solution?
You plug it in.
Mm,
Values that make a mathematical statement true.
Thank you, right? Values that make a mathematical statement true. Will 42 make that equation true?
Yes. I mean, no.
No.
How could you test it?
Plug it in.
You could check it with Desmos if you're home, but here, remember, we've done this in class already. Can you type this equation in?
You can.
And substitute that 42 in?
Yeah.
Everybody pick up your calculator, let's do it. I would never make a mistake on purpose.
You did do that. You did it.
Funny thing.
Sometimes I do make mistakes on purpose, sometimes I don't.
279.
Well, now hold on a second. I'm not just saying, okay, so you can just substitute that 42 in, but I asked you to type in the entire equation. What'd you get? That's a false statement. Remember, I want you to do the 7 times 42 plus 3 equals 45. And what does it tell us?
False.
False. So is 42 my solution?
No.
So what mistake did I make?
Okay, so boom. Instead of it's
Boom! Alright, what you got?
alright, you ain't do it right.
What did I do wrong?
Alright, you was supposed to do 7 over 1. No, you was supposed to do 1 over 7. And then
Reword that, not 1 over 7.
Divide.
1 divided by
There you
7.
go.
You was supposed to do the 1 up under the 7. Put the 1 up under the 7, and then you 7 times 7, and that's 1. Then you 1 times 1, and that's 1. And then it's gonna be 1x.
No.
I got 1x.
Bro, no.
Ah.
What you do is you trying to get x by itself, so you take 7 divided by 7, then 42 divided by 7.
Why y'all say 6?
Oh, you're supposed to do it to the other side too. 1 over 7.
Oh.
You supposed
I
to
gotta do it to the other side of the equation?
Yeah.
What's that
Yeah.
called?
Properties of equality.
There we go, right? If I don't use the property of equality, do I get an, what are these equations supposed to be?
Equal.
Not equal.
The same.
Equivalent. If I don't use a property of equality, are they equivalent?
No.
No. So I gotta use that property of
Do it on the
equality.
other side.
Say again.
Do it on the other side.
So I gotta do what to
1
the other
over
side?
1 over
1
7.
over 7.
Say that again.
1 over 7.
divided
1
by
divided by
7.
7.
Thank you. 1 divided by 7, right? So 42 times 1 is
41.
What?
I did 42. 42.
Okay, what's 42 divided by 7?
6.
Oh, is that the solution?
Yeah.
How do I check it?
Plug it in.
Plug it in, or more mathematical term is substitute it in, so check it. Yes, ma'am.
So why we just going the wrong way instead of doing the regular?
That's
Like
like
I get we learning this stuff, but that's a lot.
Like, why would just
What's
say,
a lot?
I was
why
ready
would just say
perfectly.
divide by 7? You got a question in life.
First off, now hold on, stop, and remember, okay? First off, that is the same, like we took a long time talking about it, that's the same number of steps as just dividing by 7, right? And I'm glad you asked this question, but I already told you why we're doing the multiplicative inverse, because do you want to divide by 2/5 here?
No.
No. You want to use the multiplicative inverse. Do you want to divide by 1/3 here? No. So you want to use the multiplicative inverse. So I'm trying to get you to train yourself to think about the multiplicative inverse. And I'm glad you asked that question because that's a valid question, right? But there's always a purpose for what I'm doing. Could you just divide by 7 here?
Yeah.
100%. But are you used to using the multiplicative inverse?
No.
No. So we need to train ourselves even on simple ones like this, so then we get to more complicated ones like this and this, we have an easier time remembering it.
Can we do another one? Can you give us like a practice one?
You will have time for practice later in the problems that we're about to look at, so hold on.
'Cause
Okay.
I'm gonna forget everything.
I know, which is why we're going to look at these problems in a second.
Alright.
But does that answer your question? Okay. Does that make sense? I know we may not want to do that, but long term I'm trying to help us out. Okay? So that's why I asked you to do it. Now, please hear me very clearly. I'm not going to count it wrong if you divide by 7, but
You rather us do it that way.
I would- and I would rather you do it this way because it's going to help you long term. Right? That's why I'm asking you to do this. Look at that, Andy. Don't bump that camera.
Oh no, I just had it straight right quick.
I got you. Alright. So, way further behind than I thought we were. It's okay. Learning matters, takes precedence. Okay, so number 4, the University of Alabama football team won their game last week. RIP, because they did not this week. But the University of Alabama football team won their game last week by scoring a field goal, 3 points first, and then a bunch of touchdowns without going for 2 points after touchdowns. Ask a classmate for help about scoring if football is not a sport you watch. I want you to work on A and B. Write a function that represents the total points scored. Then, at the end of the game, they had 45 points. Notice, I'm asking you for a function. So what's a notation that we might want to use here?
Equality.
Listen to the question I just said. We're trying to create a function. So what is a notation we want to use? What's f of x called?
F of X.
Well, what is that called? Function notation, right? Okay? So I'm asking you to do function notation. So f of x equals, right? So write a function that represents the number of points earned here. After you do this, right? They had 45 points. Determine how many touchdowns they scored and show your work. Any questions on these directions? Okay. I want you to take 60 seconds, and I'll tell you when the time is up, but 60 seconds to talk about this with your small group. Or not to talk about it with your small group. 60 seconds to think on your own about part A. I'll tell you when the 60 seconds are up so that you can start to have discussions. Remember, I'm looking for that active collaboration every single day. 60 seconds. Now, think about it. Y'all, 60 seconds. But I already told you that f of x equals, you just need the right-hand side. How could you represent the fact that they got a field goal, which is 3 points, and then a whole bunch of touchdowns? You don't know how many touchdowns, but a whole bunch of touchdowns after that. 60 seconds to think about how we could represent this without talking, and then we'll have small group discussions. Silently for now.
How much do touchdowns?
Yo, what does silent mean to you? 60 seconds to think on your own.
Oh.
60 seconds. I'll tell you when the 60 seconds are up. 60 seconds. start talking with your small group about how we could write this function for part A, and then move on to part B. Really quickly, has the number 45 shown up by part A?
I was looking at it too. I was looking at it too.
You don't use part B to help us.
No, part B comes afterwards.
He said only A.
Remember I said write a function that represents what's happening, right? F of x equals, how can we represent?
How many touchdowns?
And then plus 3.
Watch the score.
Okay, so, but here's the thing, do we know how many touchdowns?
Yes, what we need.
No.
We
No?
don't know
It's
nothing
just
about
that
that.
Do you know about touchdowns?
I know about touchdowns.
What do you know about them?
How many points do they count?
Each
That's a good
touchdown
question.
is 6 points.
Each touchdown is 6 points?
But they kick a field goal every time, so it's 7.
Well, the PAT, point after, right?
Yeah.
So you're saying that every touchdown is 7 points?
Oh, you lost me.
It's just, it's
Because
7 points.
this is first and a bunch of touchdown without 4 2-point version touchdown.
So they're never doing a 2 point, so you're assuming they hit the one at every
Yeah.
time, okay?
So that's
So,
it.
so you're saying 7 points for every touchdown,
Yeah.
and you don't know how many touchdowns.
No.
So how could you represent the idea that you're repeatedly adding 7 points for an unknown number of times? And don't forget, you have a field goal as well. Talk about it.
But we gotta wait out like 3 years.
7 times what?
What he just said? What? 40 what?
Yeah.
No, he said 7, right?
Yeah, each touchdown is 7.
Like that?
And then you get a field goal.
Parentheses around that?
Yeah.
No, they had that person that already had 3 points already.
So why
And then
7
scored a
times
bunch
6?
of touchdowns. And then whatever y'all said about the
That's 7. So 7. So you put 7 in for L.
Well,
No, you L don't change. It's gonna be X don't change.
Yeah.
I don't know how to do that.
Nah, this basically we got already, so this gonna be our skill. So what we trying to
Total
find.
points.
Huh?
Total points.
45
The thing
points.
is, I don't know if it's counting.
Let me ask you this.
When you score a touchdown,
When you do 7 times 3, what do you get?
This is
and then you have to try to
So what does that 21
So
represent?
that equals up to 7.
Is that part of the scenario?
Yeah, but
Because what I was pointing out is 7 times 3 is the same.
Then how many points after
7
that?
plus
Or you
7 plus 7.
So
There was my
Indicating that you have how many touchdowns?
It's 7 in all. Each touchdown is 7 in all.
The number of touchdowns?
I don't know if this is right though. That's
So
It's the
7.
number of points from the field goal. So you have some
I just
ideas
know
that are
that
correct.
I get
So
some.
think about the fact that
That's what he does.
you do have 7 points for each touchdown.
Oh,
There's an unknown number of touchdowns, and there is 3 somewhere in there. So we
They
have to
get
rearrange that to
free.
figure out an
I work
expression.
all
So
hours.
basically what I said. Talk about this group?
that's the only number
Like
that's
I
7
actually
in
know
all.
if I can.
so
He wasn't hurt this year.
we already got a number.
So you'll talk about it yet?
42. And then get 3 add 3 points.
Okay, so you
It's those 6 touchdowns. Those 6 touchdowns. And a field goal.
We're in his ranks now.
Let's go.
I read somewhere.
I believe in most.
Okay, but if I do 3 times X, that's not just one field goal.
You did it better like the whole.
That's
And
multiplied by
field
what is multiplied?
Not the actual.
Yeah. But
What's 3 times 5?
they're wrong. Alright.
So I'm adding 3, how many
I
times?
looked at it like I was wrong.
No, she just walked
Are you
around there
adding
fighting.
3?
Oh, okay. Alright.
Jesus.
So,
So we do need an X somewhere. But what do you repeatedly add?
Where you get
No.
Where you get
You
force
create
from?
something there.
no, it's not.
You just said. You got to know what you said.
Oh, Mr. Incomplete, I know who's going on, but I figured it out.
Yes, you did. You just said
I like that
force.
7x plus 3.
I
Okay,
said, where
what's
you
your
get force
reason?
from?
I never said 4.
That's what came out of your mouth.
I mean, you're not just right now, I'm just asking you
I
right
probably
now.
said-
No, okay.
Okay.
Oh,
3 points already.
Okay, so
Yep.
see,
They already got
it wasn't really specific, but
Then a bunch of touchdowns.
So we already got 3 points. So
How many touchdowns you saying they had in order to
Well,
get
do
7?
they ever get 50? Okay, go ahead. Sorry about that.
what did I said? So
she
like,
helped me out.
They already got 3 points.
Go right.
And then they said a bunch of touchdowns.
The PAT.
7. I know that's what dealing with 7.
Yeah,
How many
7.
touchdowns did they score?
One touchdown equals 7.
So why 7x? Think about
Yeah, touchdown is equal to 1.
Talk about it.
So they
Got some
automatically got
ideas?
2 points.
Okay.
No,
We're gonna talk about it. Make sure you got that.
they automatically.
3 times 7.
All right. Really quickly, I will point this out. F of x equals this. That's function. By the time you look at a, do you even know the 45?
22, and then they say without 1.
So it's not equal to 45 yet.
I didn't know you had to look at it.
Without.
Remember, all I asked for was the function.
So you don't add them.
And so you stop at the function, the 45 would come up here, but notice it wouldn't be f of x equals 7x plus 3 equals 45. It would just be 7x plus 3 equals 45.
Okay.
Make sense? Thank you. Thank you. Thank you. Thank you.
42 divided by
you.
7.
Alright, so I want to pause and I want to point a couple of things out because what I consistently saw for a lot of groups was they looked at me blankly for the 60 seconds I asked you to think on your own, and then when we started to talk about it, we were able to make sense out of it a little bit. I know I didn't get to a couple of groups, and one, that's my bad, two, I do want to introduce, I forgot to, I even said I was going to forget, didn't I? This is Miss Courtney. She will be with us the entire semester, at least until end of April, beginning of May, as our intern, and so please get to know her, welcome her into class. This is another reason why I ask that you have your name cards out, because where I have gotten to the point of almost mastering names, obviously she is just meeting you for the first time. So please have those name cards out, huh?
Anthony scared him.
I believe it. Just kidding, I'm just kidding. Alright, so Miss Courtney, she'll be a great asset to us, and so I'm really excited to have her here. So, someone share with us an function that we created.
X is 7.
X is 7. So I want to point out the way you said that is x is 7. Is that what
Well,
it's
no,
supposed to be?
plug X for 7.
So
7x.
substitute 7 in for x.
7x.
Or 7X.
Also, F do change?
What do you mean?
No,
Y'all just said.
No,
No, that's just
I
like
said
function
fill X
notation.
for fill in for put some X. No, put some X in the X.
No.
Y'all
It's not right
tripping.
there.
Remember, okay, so this is function notation.
So F did
This
change.
is defining my independent variable. What is my independent variable?
7.
X.
7 is a variable?
X.
Oh, X.
X is my independent variable. F of x, remember, is my output, my dependent variable. Okay? So 7x. Now, I want to pause for a second because this is an important idea that a lot of students miss out on, and it affects our ability to write equations like this. What do we really mean by 7x?
7.
7 times 1X.
Okay? But what does 7 times 1x mean?
7.
Like in this case?
No, just in general. So I want to pause. Remember, it's 7x. That can't just be a 7. When I do 7, and you already said times x, this is important to understanding what we are learning. Which, by the way, which lesson is this? What was the title of this lesson?
Understanding
linear
concept.
function.
Of linear functions. So this is important for linear. If I were to tell you 7 times 3, we all know that. What is it?
21.
Right? 21? Why is it 21?
Because 7 times 7 times 7.
That?
No.
Yeah.
That's a
exponent.
Thank you. Remember, repeated multiplication is an exponent.
Dang, bro.
It's okay. We're relearning some of this because these are foundations that we didn't learn it this way the first time around, and so we need to establish this. So I want to point this out. Multiplication is repeated addition. Every time that the team scored a touchdown, and we're also assuming that they got a PAT, right? Could I have done a 6 instead of a 7, assuming they didn't get the PAT?
Yes.
Right? And so it depends on the way you're defining it. So if you don't know what I mean because you don't football, that's okay. Just we're hopefully talked about it with your group. So that multiplication is repeated addition, known as an additive rate of change. Anybody ever hear that term before that we're repeatedly adding? Where have you heard that before?
Well, sure. Miss Anderson.
What do you say?
This idea of repeated addition, this additive rate of change.
I ain't never heard that.
Slope.
Slope?
Oh, yeah.
Wait, a slope is an additive rate of change?
I didn't say that. Oh, I'm just saying where I got it from.
Slope is an additive rate of change, and we have slope with what type of function? Linear functions. We need to understand that a linear function is built off of this idea of repeated addition. We're going to define that a little bit more in a second. But I want you to notice it is 7x, right? Because every time they score a touchdown, they're earning how many points?
7.
7. So why is it 7x?
Because we
don't know how many
touchdowns.
We don't know how many touchdowns
Let's
they
go
scored.
6.
Well, we'll get to that part in a second. Once we solve the problem, we know it's 6. But from the problem, do we know it's an x? Or do we know how many touchdowns? No. So we're using that variable to define the fact that we know it's 7 every time, but we don't know how many times.
But you gotta put 3 in. Where you put 3 at?
Yeah, where do we put that 3? I didn't say it was done.
Oh, add 3. Add 3. Add 3.
That's one way to write it.
That's what hard though.
No, it's not, bro. And you be confusing yourself.
You
I know.
be thinking too deep up for
I want to pause for a second, hey, really quickly. I'm going to give you an alternative way to write this that most of us probably didn't think of, but this alternative way is actually going to make more sense in the context of this problem. It's going to mean the same exact thing, meaning that these two functions are,
equivalent.
thank you, right? They're going to look different, but they're still the same. What was the first thing that the University of Alabama did? They what?
Score 3
Score
points.
3 points.
They scored 3 points a touchdown. So where could I have started this equation?
3.
I could have started, well, just with a 3, a positive 3. And then what happened?
They scored a bunch of touchdowns.
They scored a bunch of touchdowns. So each touchdown was?
7.
Are those equivalent?
Yeah.
Those look different, but they're still the same. This one is actually my favorite way to write the equation of a linear function. It's either way that you want, but I'll go into more details about this in a second. Does anyone recognize this general equation of a linear function, though?
Oh, sorry. I know. I never say you just like it.
Yes, you have. 100% no, you have. How about you look at your graphic organizer, look for a term that might describe this f of x equals 7x plus 3.
A function.
It is a function, and it is function notation. It's actually a term that we haven't defined yet.
Equivalent.
Well, we have equivalent equations. These are two different equations that look different but are the same.
Evaluating
Hold on, listen. What I'm asking is, there is a concept on there that is the name of this type of linear equation.
Linear function.
Okay, if we're evaluating a function, that's not the name of a linear function. It is a linear function, but I'm asking for the name of this type of linear function.
Slope-intercept form?
Oh, the
Of a linear
slope-intercept form of linear function.
I see
Okay.
it now, because that's pretty much y.
Remember, what is y? That is the,
Independent variable.
not independent.
I mean dependent.
Dependent
And
variable,
x
that's
is
my,
an independent.
remember, y is my dependent, okay? F of x is my dependent, my output, okay?
You got your rate.
And what, okay, so first off, the slope-intercept form of a linear function, which I'll go ahead and tell you. How many of us have seen it written out in that many words?
Never.
Never. What have you always said?
Slope-intercept.
Slope-intercept. And whenever I ask, hey, what is slope? Students tell me y equals mx plus b, which is why I used full words so that we know the difference, right? This is not just slope. This is the slope-intercept form of a linear function. What is the slope-intercept form?
Y equals mx plus b.
Looking right here, what is my m, my slope?
Which one?
It's 7.
What is 3?
7x.
I'm just asking the slope.
Oh.
7.
7. What is my b?
3.
That's also known as my y-intercept. That name is not to confuse you. That name is to tell you exactly what you need for that equation of a line. The two things you need for slope-intercept form are the slope and the, which intercept? Y-intercept. That y is not a part of it, but slope-intercept is literally I need slope and intercept. And I see some of us looking up here. Are those some details that we might want to be writing down on our notes, not on the graphic organizer, that's for you to reflect on later, on our notes, bolding the fact that we are talking about the slope-intercept form of a line. Anthony, you look like you got a question.
What I'm saying though, that's the same thing we just did up there.
That's the point. My point is that this equation we just wrote is the slope-intercept form of this linear function.
I'm saying though, them two the same. Number 3 and 4 the same question.
Oh, that's wild. I had no idea.
You thinking too deep off me. Come out.
Now, I do want to pause. I do want you to notice this is a function. Is this a function?
No.
No. There's not two variables there, so it's not a function. That is an equation. That is the same as part
B.
B. Okay.
You're making my head hurt.
Means you're learning. Remember, I've said this before. If your brain's not hurting a little bit, you're not growing. Every time I go to the gym, I hurt a little bit. That's how I know I'm getting stronger and in better shape. I still should be in better shape, but when I hurt at the gym, I know that I'm breaking down my muscles so they can build back stronger.
Yeah, that's why my head.
Yeah, I'm always
that's why
sore.
Your head
I am consistently sore. I recover a little bit on Saturday when I just run, and then Sunday I'm okay, and then Monday it all starts over.
Stop thinking so.
That's all.
Okay.
Bro, you gotta think hard. We in Mrs. Kenny class.
Thank you. All right, really quickly, I do want to point out there is an alternative way, right? We just talked about this, that this is also equivalent, right? Another way to write slope-intercept form is y equals a plus bx. And it's important, this will tie into what we call exponential functions later. It's important to notice here, is this b my y-intercept?
No, it's your
It's
slope.
changed to the.
It's your slope.
That's my slope.
And A your y-intercept.
Because remember, what is slope? That, remember how it's being multiplied? So my slope is my what kind of change? What kind of rate of change? If it's being multiplied, what am I repeatedly doing? Additive, right? Rate of change.
Addition.
So, don't forget slope, and you should probably have, I think that's one of the concepts on the graphic organizer as well. So we want to probably write this on our notes and bold these things, but slope is a constant additive rate of change. And that's why, if I'm repeatedly adding, what operation shows repeated addition?
Slope.
Multiplication. Remember, slope is that additive rate of change for a linear function, but the operation that shows repeated addition is multiplication. Notice how my slope is what times x, or is what to the x? It's being multiplied. Right here in this equation, the b and the x are being what? So that's my slope, right? Because it's being multiplied. B is slope here, and a is the what?
Y-intercept.
There you go.
Mr. Kenny, I know why I messed up. Because I was trying to solve it, but it was just telling us to write a function that represents the total point scored.
Correct.
We
And
don't gotta
that's important
solve
to notice. A function has both an independent and a dependent variable. You need f of x and x.
Mm-hmm.
I just wanted a function for number 4. Or for A. For B is when we solved it.
There you go.
So we're gonna have to add the equal sign. Equal 45 at the end.
Well, notice, you don't have to put it into the end. We want to notice, what is x representing? Remember, that was something we didn't know. That was the number of
Total
touchdowns.
points scored. I mean, touchdown.
Remember, number of touchdowns. This is why we want to define variables a lot of times. So f of x was what?
Function.
It is a function, but what is it representing, right? X represented the number of touchdowns.
No.
F of x is how many?
Total.
How many wait.
How many total points?
There we go. And so, because there's total touchdowns and there's total points. Remember, 3 was a number of points. And then I'm adding to it the number of points from touchdowns. So f of x is my number of points.
So all you do is 45 equals 7, 8 plus 3.
Because if 45 is my number of points, that can take the place of
X.
X, the function.
f of x.
F of X.
If we didn't put it in the front, is that like a
Does
big deal?
that mess it up?
No.
No, I mean, if you solve that equation, I'm not gonna go through all of that again because literally that's number 2,
Yeah.
right? I'm not gonna go through all of it again, but it's gonna give you the same answer. X is equal to what? 6. I'm just pointing out that 45 is my number of points, so I'm substituting it in for f of x. I'm substituting it in as the output.
Okay, okay.
I'm gonna pause for a second. I'm gonna let you write down some notes. Because remember, these notes are what you're going to go back to reflect upon in your reflect upon with your graphic organizer to reinforce everything you've been learning. So you need to have the best notes possible, not just writing down equations, but explaining.
I have a question.
Yes, ma'am.
When is that due?
The graphic organizer?
Tomorrow.
Not the entire thing. Remember, only through linear functions. I'm going to glance at it in a second to make sure. But we talked about what a linear function is with this. We talked about what slope is from this. We'll go into more detail about that in a second. We talked about slope-intercept form. And
What are we doing through again?
Oh, we talked about linear
functions.
functions.
We talked about mainly the front anyway though.
Huh?
We've talked about most of the front anyway.
Correct. That's why I'm asking
I
you to
just can't
reflect and write about it.
I can't remember what you.
Well, so where can we go back to see some of these terms? Both this task, we should have a lot of these terms defined, but isn't it also on your blue Desmos as the new back of the book daily assignment? I think we talked there about algebraic expressions and equations. We talked about solving and solutions, right? I will say you don't need to do evaluating. No, evaluating functions and simplifying. Please note that's numbers 3 and 4 on your blue sheet. That'll help you.
So Desmos.
Yeah, the Desmos thing, the evaluating functions and simplifying, that's numbers 3 and 4, because I haven't clearly said that, but, and intercepts is also on Desmos. And that should be there, but I understand if we don't fully define that well, but you should be good to go on that. Any other questions about this before we move on? Y'all didn't think we could talk that long about numbers 3 and 4, did you?
No.
Do we do the blue sheet tonight?
When's
that's not
when's that blue Desmos the new back of the book
Next
due?
Tuesday.
Next Tuesday.
The 18th.
Oh, you moved it?
It was always the 18th.
Dog.
Dude,
Where
you
you
didn't
been
turn
at?
in the blue one, but he let us
What
redo
is
it.
due tomorrow? The graphic organizer and what
And
else?
math literacy.
Math literacy is due tomorrow.
Oh, okay.
If, from now on, if I were you, I'd probably write the due date at the top of the sheet. Remember, y'all have graphic work, or you have enrichment every single day. I would knock those things out during that if you don't want to do it at home.
Oh, good girl. Trading. Oh my God.
Hey, we aren't talking about teachers in this class.
No,
especially.
no, I'm not talking about her.
Okay.
Like, she pretty much do what you do. She still make us do her work in her enrichment.
I mean, you can do whoever's work through your enrichment. Alright, so here's the thing. And I know some of us are going to get stuck with this one, but that's why we're in a small group to discuss and help each other out. We have a table here, and notice we are going beyond what is due tomorrow. We're getting into understanding concepts of linear functions, mathematical flexibility between function representations. What representation is this called right here?
A table.
A table. It's also called a tabular representation when we are talking about what the representation is, but it is a table. And we're talking about linear functions. So what is